This section focuses on converting from the mass of one compound to the mass of another. Here we have an example problem. I'll walk you guys through it. So given the following equation, if 3 grams of H2 were produced, so again, here's our number, this is our given. So we're going to write that first on the top left. So 3.00 grams of H2. If that many grams were produced, how many grams of aluminum reacted? So if we look at our chart here, we need to convert from the mass of our known, so the mass of our hydrogen, to the mass of our aluminum, which is our unknown, because that's what we're trying to figure out. So in order to get from the mass of the known to the mass of the unknown, we need to have 4 different fractions. It takes 4 steps here. So let's go ahead and put those fractions in. So 1, 2, 3, and we need one more. Okay. Now remember, whatever's in this circle here, this tells us what's going to be going on top of each of those fractions. So on top of our first fraction, it's mass of the known, so that's where we have grams of H2. On top of the second fraction, we're going to have moles of the known. So we're going to have moles of H2. On top of the third fraction, we're going to have moles of the unknown. In this instance, our unknown is our aluminum. So we're going to have moles of aluminum up there. And our last fraction is going to have mass of the unknown. So mass of our aluminum. Remember, now we got to figure out what's going on the bottom of each fraction. All we have to do is take a look to see what's on the top left, and that's what's going to go immediately on the bottom right. So grams of H2 will go down here. Since moles of H2 is up there, moles of H2 will go down there. And since moles of aluminum was on the top left here, moles of aluminum will go on the bottom right there. Now we have to go figure out our numbers. Take it a fraction at a time. Now, in our first fraction here, or our second one, we have moles and grams on top of each other. Remember, anytime this is the instance, the number 1 will always go with moles. Now, we have grams. This is where we have to go take a look at the periodic table. But luckily for this problem, they give it to us already. So the molar mass of H2 is 2.016. 2.016 grams. All right, so that fraction is done. Moving on to the next fraction. This we have moles over moles. Remember, anytime we have moles over moles, we need to take a look at our recipe. Take a look at our balanced equation right here. So, moles of aluminum, we look for aluminum. The number 2 is in front of the aluminum. Next, we have our hydrogen. Take a look at our hydrogen. We notice that the number 3 is in front of the hydrogen. That's our coefficient, so we're going to put that in. So now that fraction is set. Our last fraction here, we have grams over moles again. So same instance, whenever you have grams over moles, the number 1 always goes with the moles. Next, we look at our periodic table to find the grams, but luckily for us, they give it to us right here. The molar mass of aluminum is 26.98. So 26.98. Now all our fractions are set. Now all we have to do is multiply and divide. Remember, anytime you see a number up top, you multiply. Anytime you see a number on the bottom, you divide. Hey Google, what is 3 times 2 times 26.98 divided by 2.016 divided by 3?
The answer is approximately 26.765873.
Hey Google, say that again.
Sure. The answer is approximately 26.765873.